So our first example today, identify input, output, and the process for adding two numbers and then develop suitable algorithm. Right. Okay, first of all, what we are supposed to do is identify what input is. Then what process is and what output is. That's the first step. We call analysis the problem. Analyzing our problem. So when you're given a problem to solve, you try to identify input, output, and process. Yes, can one of you tell me what is the input? Yes. So our first example, example number 1, question asks us to identify input, output, and the process for adding two numbers. So the two numbers, isn't it? Yes. The input is the two numbers. So I'm going to separate this out. I'm going to say, okay, first number and the second number. So I'm going to separate the two, definitely the two numbers, second number. So that's the input. Good, Neha. Neha answered the question. Next, what is the output? Yes, can one of you tell me? What
Answer.
is? Yes, Malidu?
Answer. Out.
Yeah, what is the answer? We are getting two numbers, and what is the output we expect?
Add in first number and second number, we get answer.
That means the addition of the two, right? We can say, right, total the two numbers, isn't it? So that's what we expect. We right now we don't know what these two numbers are. It could be 1020, it could be 1520, you know, could be anything. Right, what is the process? So how do you convert the two numbers to get the total?
By adding.
Yes, by adding the two numbers. So simply I can say, okay, first number plus the second number, isn't it? Right? So that's the answer for the first part. So when you add in two numbers, we have to identify the input as the first number and the second number. We identify the two numbers. Then the output is the total of the two numbers. And then the process is we add these two numbers. So simply you can say addition of the two numbers, so that's also okay. Right. Let's look at the second part. What is the second part? And then develop an algorithm. Okay, so the second part of the problem is we have to come up with an algorithm. Simply algorithm means the steps. We want to know what is the first step, second step, third step, fourth steps, and so on. Right. Can somebody tell me, like, what should be the first step? පළවෙනි step එක මොකක් වෙන්න ඕනද? Yes. What should be the first step? If you write a computer program to do this one, what should be the first step? The computer has to first get the first number, isn't it? We need to know what is the first number. So we can say get input, right? And different terms we can use. So let me use input, right? So I'm going to use input. So first of all, that means you are getting the first number, right? Now, can you tell me what is the second step?
Input second number.
Yes, exactly. We want to get the second number. We have to get second number. Yes. Third step.
Adding.
Yes, we have to add first number with the second number, right? So we can say first number plus second number. So to make it very simpler, we can have a variable, say total, and we can assign this addition as a total. So we can write down as total equals first number plus second number. අපි මෙතනදී කරපොතේ මේ දෙකත් එකතු හොයලා අලුත් විචල්යකට දාගත්ත total කියලා. So it's easier for us to next step. Yes, can you tell me what is the final step? Yes, what is the final step?
We get the answer.
Yeah, we need to output this. So we can say output total, print total. So I'm going to use print total here. Right. So as you can see, what we have looked at is very simple addition problem. And using this, we identify how to identify input, process, and output. And once you identify input, process, output, right, we discuss how to put it as an algorithm. So algorithm is the steps of the solution, right? So how do you solve? So later in this session, we will learn how to convert these steps into a programming instructions, or using a suitable programming language, we can convert these statements as a program. So that's exactly what we are going to learn this. Okay. If you finish up to this point, can you please raise your hands? So in Zoom, we have, if you go to more, And if you go to reactions, you can find the raise hand option. Right. Almost finished. Kanishka and Neha finished.
Yes, sir.
Okay. Right. Let's move to the next one. You can lower the hands. Right. Let's move to the next one. Let's look at another example. Example number 2. So example number 2, identify input, output, and the process to find the area of a rectangle. Develop a suitable algorithm. Right. The first thing under the development algorithm, let's take down developing algorithms as the topic, and we'll write down this. Let's write down development algorithm, and then let's write down this. There are different ways to represent algorithms. There are different ways to represent algorithms. Such as ways to represent algorithm, such as flowcharts and pseudocodes. P is silent. Flowcharts and pseudocodes can be used to develop algorithms to represent the order of executing instructions. Right. First of all, let's look at flowcharts, right? Don't take down this table. First of all, let's write down flowcharts. And flowchart means use of graphical symbols, right? So let me take down that first. So write down flowcharts, and under the flowchart, write down this. Flowcharts can be used to represent steps of an algorithm by using the following graphical symbols. Right? Flowcharts can be used to represent steps of an algorithm using following graphical symbols. Now we discuss the solution we have to provide step-by-step manner. And to learn this, we are first going to use graphical symbols. So you can see these are the graphical symbols. So this is more or less oval shape. And this is parallelogram, rectangle, diamond shaped block. These arrow keys, and this is a small circle. Okay. First symbol that we will use is normally oval shape, but although we say oval shape, you can have like two parallel lines, and then you can use half circles. So this can indicate start and end of an algorithm. So whenever we have start, we can draw simply like this. We can say start, right? Similarly, in the flow chart, to end also we can have the same. We can have end like this. So this will indicate the beginning and end of the program, basically the algorithm. Then parallelograms we can use to indicate input and output. Now, for example, the example that we have discussed, we have to input the first number and we have to input length. So whenever you want to represent an input, you use parallelogram, and inside that we can say, okay, input length, right? So we can indicate. Similarly, the output like print statement. So we can say print area, right? We can draw like this, right? So basically parallelograms are used to represent input and output. Third, we have rectangles. We have rectangles. Rectangles indicate process, right? If you perform calculations, data manipulations, like when you say area equals length into width, this is a process. So we have to enclose this with a rectangle. Then we have diamond shaped blocks to represent decision. You check something, you make decisions, right? Now, for example, we can check something, like we can ask question like, is the weather rainy day? Is the weather is a rainy day? Or we can check something like, right, is the marks for, let's say, a particular subject, marks, whether it's greater than or equal to 50. So normally these decisions are normally have two outcomes, either yes or no. So basically we are using yes or no questions. So one side we will have a branch if it is yes. If it is no, then another branch. Then there are flow directions. You start, and then let's say you go to input, And then you print area, the flow chart, so you can indicate what it connects, flow lines. It will be an arrow. And to connect finally part of this, so let's say after this one, we are going to finish. So we can have a label for the circle, let's say A, and then you can start from somewhere else, starting from A. So this is to say that after this, you are going to start from this point. So this is called connectors. Especially when the space is not enough, if you want to continue your flow chart in another page, you can use a connector. So let's move to the first example. Let's draw a flow chart to add two numbers. We have already discussed the steps. If you have two numbers, we have to get the first number, then we have to get the second number, then we have to perform the addition by adding the first number with the second number. Then we need to print the total. That's all. Right? So let's start. My first step is I will draw the start. So that's my first step. It will be start. Right. So indicate the start of this. Then we know we have to get input. What do we have to get? First number, isn't it? First number. And this is input. So we have to use correct symbol. And then we can connect using a line, flow line. That's the first number. Yes, next. We have to input second number. So you input second number. Again, that's also input. Parallelogram. What is the third step?
Process.
Yes, we say total equal first number plus second number. So this is a process. So it should be enclosed with rectangle block, right? So we have to have rectangle block like this. So you are connecting the third step. Yes, what is the final one? What is the final one?
Output.
Yeah, output, or we can say print total. So again, it's an output. So remember to use the correct symbol. And finally, right, we have end. Right, that's a flowchart. Right. Next, we'll look at There are three types of control structures. Control structures mean the way we can develop algorithms. So let's write down a topic called control structures, right? And under that, let's write down there are three types of control structures. Use when developing algorithms. There are three types of control structures used when developing algorithms. Used when developing algorithms. They are sequence, selection, and repetition. So basically what we are trying to tell here, when you write flowchart, there are three types of control structures. Control structure means structure is slightly different from each other: sequence, selection, and repetition. So in this part, we will look at sequence. Now, sequence means you execute instructions one after the other. So in this figure, you can see, first of all, you complete the task 1, then you move to task 3, then you move to task 3. Let me ask a small question. Can you tell me our previous flow chart, is it a sequence or not? Previous one. Yes. Can someone tell me? Our first flow chart we have drawn, adding two numbers.
Sequence.
It's a sequence, because in that one as well, from top to bottom, we are going to execute everything. So it's sequence. So you have a sequence control structure in the previous one. Okay. Here is another example for sequence. Example number 2. Draw a flowchart to calculate the area of a rectangle. Draw a flowchart to calculate the area of a rectangle. Okay, so let's discuss the answer. First of all, let me put some text, right? I'm going to type the text. So basically, we can start saying start, right? And then we can say input, let's say length, input, width, and we can say, okay, area equals length into width Then we can say print area. So I'm going to put in somewhere here because otherwise it will stuck with this one. So this is just my the values. Now let me draw the symbols, right? So the start symbol we discuss it similar to oval shape. So this is how you may draw that. And similar one comes with end as well, right? And then all the inputs and the outputs, we have to have parallelograms. So we can have like this. With also we have like this. Output here also like this. Okay, right. And this one is a process. We discussed that it's a calculation. Calculations, manipulations, we consider it as a process. Right, now we have to connect using flow lines. So first step is you get the length, get the width, find the area, print the area, and finally, this is the end. Right. If you have finished up to this point, so in the third example, let's look at a similar problem, another problem. I want you to draw a flow chart to calculate the area of a circle. Area of a circle. Please draw and send it to me using WhatsApp. So the first thing that when you are given a problem, identify what are the inputs. Now, for example, here, to find out the area of a circle, what you should get as input. Then think about the output. Okay, what is the output? Then given input and output, how process should be done. So let's start with the input first. Yes, what is the input for this problem? Yes. Now to find the area of a circle, what we should know?
Radius.
Yes, we need radius. That's all. Right? So what is the output?
Area.
Yes, area of the circle, right? Area of the circle. Now given radius, how do you find given radius? How do you find the area?
By multiplication.
By multiplication what?
Radius and y.
Area equals, yes, pi,
2 pi r.
not 2 pi r, 5r square, right? So we can say, okay, if you take this as a pi value, you can say a radius into radius, right? Right? We can put it like this. Now, since we know this, right? Now it's a matter of drawing this. So let's start with typing what we need. So we can say, okay, we can start. It was next we can say input radius. Then we can say area equals yes into radius into radius. Right. Then we can say print area. And finally, we can say stop, or we can say end. That's all right. So now draw the shapes. Now we already discussed, yes, the shapes. Imashi asks whether we want to get pi value. Usually you don't need to, because pi value, we can, it's a constant, right? It won't change. So usually we'll get input whenever things changes. And pi value you can find out, isn't it? Pi is already available. Constant values, we can assume that they are already available. There's nothing wrong if you want to get it, but there's no real use of that. I have seen like half of the class, they use input pi as well, but it's not necessary, right? That's why I avoid this one, because it's a fixed one. So in the calculation, I can just put the value of pi here. So this is the start, and this is the end, and these are inputs, these are outputs, and this is process. That's all. So we can draw the flow lines. First of all, you get the radius, then you find the area, you print the area, finally, that is the end. Okay, if you finish this one, right. Let's move on to the next one. You can lower the hands. Now we have already seen the sequence control structure. Sequence means we are going to execute all the steps from top to bottom. Next, we are going to look at, right, making selections. Right, making selections. Selection means based on a condition, we are going to take different paths, right? So let's write down selection. Under the selection, we can write down what the selection means. So we can write down the selection control structure can select between two paths. The selection control structure can select between two paths. we'll say alternative paths. Between alternative paths. Right. When you say selection, okay, Malindu. So the selection control structure, we can select between two alternative paths. So this is actually part of the flow chart. So the selection structure look like this. You will have a condition, and then the condition may yield either true or false. If it is true, then you are going to execute this path. If the condition false, then you are going to take the other path. So that's why I said the selection is between two alternative paths. So let's draw this one, write selection and this description. And then can you draw this one? Okay, when you finish, you can raise your hands. And actually with that one, I would like to finish for today. And then we will have examples. We will discuss example for this week. Sorry, next week.